Direct current motor. By the end of this lesson, you should be able to describe how a direct current motor works, state factors that affect the speed of rotation of an electric motor. Look around your houses that use electric motors. Almost every electrical appliance that produces mechanical movements uses an electric motor. How does an electric motor operate? An electric motor is a machine that converts electrical energy into mechanical energy. How many types of electric motor do we have? Name the different types of electric motor. Electric motors are classified as either DC or AC, depending on the type of power supply that they use. An alternating AC motor works on an alternating current supply. An alternating current flows back and forth in a circuit. A direct current, or DC motor, uses direct current, which flows continuously in only one direction in a circuit. A simple DC motor consists of 1. Two magnets. The poles of the magnets face one another to provide a uniform horizontal magnetic field. 2. An armature or rotor placed between the magnets. The armature is a piece of soft iron core with a coil of wire wound around it and is free to rotate. Three. A commutator which is split into two sections. Each section is connected to one end of the coil and turns round with it. 4. Two brushes that press against the two sections of the commutator and are connected to a DC power supply. Electric motors are designed to produce continuous rotation as long as there is current flowing in the circuit. How does a direct current DC motor work? What happens to the armature when current flows through the circuit? Click on the switch to find out. When the switch is switched on, the circuit is completed and the armature rotates. Why? Notice that the wire segments PQ and RS of the coil are in the same magnetic field. The current flows from P to Q, then to R, and then to S. When current flows through a wire, a magnetic field appears around it in the form of concentric circles. Determine the magnetic field direction for the wire segment PQ and RS. The direction of the magnetic field lines of the wire can be determined by using the right-hand grip rule. When the magnetic fields of the two current-carrying wires interact with the magnetic field of the permanent magnets, forces are resulted. Determine the direction of force on the wire segments PQ and RS. The direction of force on the current-carrying conductor in a magnetic field can be determined by using Fleming's left-hand rule. When the magnetic fields of the two current-carrying wires interact with the magnetic field of the permanent magnets, a catapult field is formed. The wire segment PQ experiences a downward force, while wire segment RS experiences an upward force. Forces are of equal magnitude, but opposite in direction. These forces produce a turning effect or a couple on the coil, thus causing the coil to rotate in the anti-clockwise direction. When the coil has reached the vertical position, the commutator is not in contact with the brushes. As there is no contact with the power supply, there is no current flowing in the coil. The magnetic field lines around the coils disappear. Hence, there is no force acting on the coil. However, in this vertical position, the momentum of the coil causes it to continue in its direction of rotation until the commutator regains contact with the brushes again. When the coil continues to turn half of a rotation to the horizontal position, the commutator comes into contact with the brush and current flows from S to R, then to Q, and then to P. The exchange of contact that each commutator makes with the brushes every half rotation ensures the same current direction in the armature. The same current direction on the armature produces the same direction of forces on each wire segment, thus causing the armature to continue turning in the anti-clockwise direction. Click on the switch to start the rotation of a DC motor. What can you say about the rotation speed of the motor when the current is varied? Drag the rheostat slider to vary the current. What can you say about the rotation speed of the motor when the strength of the magnet is varied? Drag the slider to vary the strength of the magnet. What can you say about the rotation speed of the motor when the number of turns on the coil is varied? Drag the slider to vary the number of turns on the coil. What are the factors that affect the rotation speed of the electric motor? The factors that affect the speed of rotation of the electric motor are 1. The amount of current supplied to the motor, 2. The strength of the magnetic field, and 3. The number of turns on the coil. The rotation speed of the motor increases when the amount of current, the strength of the magnetic field, and the number of turns on the coil increases. How do these factors affect the rotation of the electric motor? How do these factors affect the rotation of the electric motor? The speed of rotation of the electric motor increases when there is an increase in the amount of current flowing in the circuit, the strength of the magnetic field, the number of turns on the coil. Things that you need to build a motor. One wooden block with metal tube through the center, one wooden base, one metal spindle, two rubber rings, one iron yoke, two split pins, a 3-volt battery, connecting wire, 2 magnets, 4 studs, cellophane tape. Steps to be taken. 1. Insulate one end of the tube with insulating tape. 2. Wind about 10 turns of wire in the groove around the wooden block. This is now the armature of the motor. 3. At the ends of the wire, remove 2 centimeters of insulation. 4. Fold the ends of the wire back on themselves. 5. Arrange and fix the wires neatly against the sides of the tube using rubber bands. These bare ends of wires act as the commutators. 6. Cut 2 half-meter lengths of wire. Remove 1 centimeter of insulation from one end of each wire. 7. Fix the wires to the wooden base using studs. These bare ends of wires act as the brushes. 8. Put split pins into the base and hold the armature between them. Insert the axle rod through the split pins and the tube. 9. The armature now should be able to spin freely. 10. Place the magnets on the yoke with opposite poles facing each other. 11. Connect the brushes to a 3-volt battery. 12. Give the armature a slight push to get the motor running.